Okay, this is the Geometry Unit 1, Lessons 1 and Lesson 2 video. The reason I'm combining these two is mainly due to the fact that the material for Lesson 1 is more or less reading and vocabulary. So I might mention a few of the terms in there, but I think that one's more or less manageable. You just need to pay close attention to the vocabulary words at the beginning of the lesson and go ahead and read through that one. You'll understand why when you get into it. So what I'm saying is for lesson 1, not a lot for me to say, but I am going to jump in with lesson 2. So in lesson 2, they're introducing just some key terms and some basic ideas about geometry. And so I'm kind of going to walk us through some of that and talk through some of the terms. So in geometry, we have these things called undefined terms. So undefined terms are kind of the basic building blocks of everything that we do in geometry. So we're going to talk through each one of those and kind of talk about what they are and talk about the way that we write them, the way that we draw them, the way we talk about them, just so kind of we're all on the same page with that stuff. So we'll start with points. So the first undefined term is points. Points are represented by a dot, and it will always be accompanied by a letter. So this is point A, also known as, again, I'm going to put it in quotes because the way we say it is literally just to say point A. So when you write or say this, you would be talking about point A. The thing that you need to know about points is that points identify location only. They do not have a size or a shape. So that is your first undefined term, are points. So that's our first one. Our next undefined term is a line. So a line is usually going to be represented by a straight line with arrows on either end. And typically, it's going to be labeled with 2 points. So we'll call this X, Y. And if I was looking at this line, I would refer to it as line XY. And if I wanted to notate it, I would notate it as one of two things, either line XY with that symbol that you see there, or I could also call it line YX. So I should go ahead and point out that the two that you see there, XY and YX, these refer to the same line that you see here, as does this written out version. So most lines are going to be written with that kind of notation and with this kind of diagram. Now, in some cases, you will have lines that do not have any points. They will just have a small lowercase letter kind of on the end near one of the arrows. If you see that, this would be referred to as line M, or you could write it just like we did the other ones with an arrow above it. So know just that there are 2 different ways we sometimes see lines written or drawn, and they are either with points or with just the small lowercase label. So this functions more like a label, the M does, whereas this refers to actual points, X, Y. Notice again that X and Y can be in any order for a line. Now, underneath the category of line, we have some other kind of things that we need to be aware of. So let me jump over here and these 2 are not considered undefined terms. They are kind of subcategories underneath line, and they are going to be ray and line segment. So array. Array is a line that has one place where it is going on forever and one place where it just ends. So let's call this PQ. And so rays are always named starting at this end point right here and going in the direction of the place where it goes forever. So it would be called PQ like this, or it would be called ray PQ. So that's just so you know how we notate rays. Line segments are a category that refers to things that have two endpoints. So a line segment is going to look like this. There's going to be a point on either end. Let's just call this RS. This line does not go on in either direction. It stays between R and S. And so we would call it line segment RS. Also could be written as RS with just a line with no arrows, or SR, line with no arrows. So I kind of want to identify a couple of key differences between these different types of things. So first of all, lines go on forever in either direction. Rays go on forever in just one direction. And line segments only contain the points between the 2 points. So if I was going to say something about lines, I would say that they only have one dimension, length. There is no thickness to a line. It just is like this. And it is a straight path going on forever. A ray is a straight path going from one point and forever in one direction. And then a line segment is just the points between 2 points. All right, so then the last undefined term is going to be a plane. So a plane is two-dimensional. And in reality, the screen that I'm writing on is a plane. But in order to kind of show this, we tend to do a little parallelogram like this. And the most common way you're going to see a plane identified is actually with an uppercase letter in the corner. So this would be called plane M. Now, the other thing that you might see sometimes is you might also see some points in that plane. And if you see that, you could also call this plane A, B, C. In other words, the plane that has the points A, B, C. So I want you to see that because I want to make sure you understand the differences between when I'm naming a plane with points and when I'm naming it with just this label. And really the difference is that you will know it because these will actually have points that you can see on the diagram, whereas the M does not have a point. The thing you need to know about planes are just some conceptual things is a plane is a flat surface. And it has two dimensions. Those dimensions are length and width. And also, much like a line went on forever in both directions, it's important for you to understand that in reality, even though there are lines showing kind of a boundary around this plane, in reality, this plane extends forever in every direction. So it's a really important concept. So just because my screen or just because a piece of paper ends, the actual concept of a plane in geometry goes on forever in every direction. All right, so I'm gonna shift gears for a second. I'm gonna post these notes for you on our classroom page, but I'm gonna shift gears for a second, and I'm gonna talk through Another thing that is in lesson 2, which is these postulates. And so once they give you these information about points, lines, and planes, they move on to these 4 postulates. So I am going to just draw a diagram for each postulate. I'm not going to write out the entire definition, but you have the first one you come across is 1.2a. And 1.2a says that through any 2 points, there is exactly 1 line. In other words, if I draw 2 points, let's just call this point R and let's call this point P. If I draw 2 points on a diagram, there is only 1 line that goes through those points. Obviously, that one's not very straight, but you catch my drift. So that if I were to draw a different point, there is only 1 line that goes between R and S, and only 1 line that goes between P and S. So the important concept here is that through any 2 points, 2 points form 1 line. There is not any other line that goes between R and P or R and S or P and S. These lines are the only lines that go through those points. All right, let's jump to the next one. 1.2b. In 1.2b, it says that through 3 points, there is 1 plane. That should be pretty clear. If I have 3 points, let's call these X, Y, and Z, there is only 1 plane that contains those points. And really, in reality, it's the screen that I'm drawing on right now, right? It's this flat surface that contains them. There is not another plane beside that one that contains those 3 points. There are some videos on the lesson that you might want to watch just to kind of drive home some of these concepts. So let's keep going. 1.2c. It says, if 2 points are in a plane, then the line that contains those 2 points also lies on the plane. Okay, so it's saying we have a plane, and we have 2 points in that plane. Let's call this D and E. So what it's saying is that because D and E are in this plane, the purple plane that I've drawn, then if I were to connect them with a line, they would also, that line DE, is in the plane. So in other words, in this case, if D and E are in the plane, so is line DE. And that is what we see here. All right. 2 more, and then we'll be done. 1.2D. It says if 2 lines intersect at 1 point. This is pretty straightforward. You know this intuitively probably, but if I have these 2 lines, it's clear that they intersect at just 1 point, and that is this point right here where they intersect. They don't intersect in any other place but that one place where they intersect, and that is true of all lines. Any 2 lines, they intersect at just 1 point. And then our last one is probably the hardest one to illustrate, 1.2e. It says that when there are 2 planes, then they intersect in exactly 1 line. And I think the easiest way to think about this is if you look at, maybe you're sitting in your room and you have your the floor of your room. Let's say the purple is the floor of the room, and the wall. of your room. Okay, so the green is your wall. I'm going to go back, I messed up a little bit. The green is your wall. You can see that, again, even though these go on forever, right? Imaginary go on forever. The place where they intersect is this place right here, which is a line. And so we say, when we talk about this in geometry, that two planes intersect at one line. Which I think it is. In one line. So that line in red would be the intersection between the green plane right here and the purple plane down here. They intersect at that red line. So that's more or less what you need for this lesson. Most of the questions are more vocabulary based, and they just want you to look at different diagrams and identify some different things. So let's jump to another drawing.